Okay. We're going to start with a little graph. You do not need to write the this paragraph, but we will have a little table and a little graph here. And I apologize, I'll move it up in just a second. Example 1, x and y intercepts. X and y intercepts. Again, you don't have to write the paragraph, but we will have a little table of time and distance.
How many does it need?
I'll move it up here in just a second. So it goes to 6. All right, man, that's annoying. I don't know why. Let me see if I can go out a little bit here to get it all. There, that's a little better. A little better. Okay, there we go. Okay, a turtle is 30 feet away from an oak tree, and he starts crawling towards the oak tree at a rate of 5 feet per hour. Pretty darn slow, but it is a turtle, so I guess that makes sort of sense. Okay, complete the table and the graph, and then we're going to talk about the meaning of the intercepts. We're going to talk about what the x and y intercepts are. So first of all, we have a little table here. This is hours, the time unit for hours, from 0 to 6. And we have the distance. This is the distance away from an oak tree. That's what that represents. And so we are going to make a little graph. And it doesn't have to be a beautiful graph. It just has to be a little graph. But on our horizontal axis here, we actually are talking about time in hours. And we have 0, 1, 2, and that would continue 3, 4, 5, and 6, 7 if we wanted to. And on our vertical axis, we have the distance from the oak tree in feet. Starting at 0, the origin, and then 5, 10, I guess we're counting by 5s, 15, 20, 25, and 30. So go ahead and make yourself a little graph. Again, it doesn't have to be perfect, just has to be there. It's really important that you label your horizontal axis, and important that you label your vertical axis, because really, in real life, math doesn't have x's and y's. We're talking about real things. Josh, you can put your phone away because this is math class. So we want to make sure that we have a complete understanding of the thing that we're looking at. So first of all, our little turtle, Timmy the turtle, where is he right now?
Walking.
He's walking where? From where?
The distance from the oak tree.
Okay, what was his distance from the oak tree? 30 feet. Yeah, he started at 30 feet away from the oak tree. So that is what we call his initial position, his distance. Right before we started, timing him, we noticed he was 30 feet away from the oak tree. So when time was 0, when we hadn't even started, he was up here 30 feet away from the oak tree. Then he started crawling towards the oak tree, so he's getting closer to the oak tree at a rate of 5 feet per hour. So if he went 1 hour, how far did he go?
10 feet. Or how much?
1 hour.
Was he going?
He went 5 feet. So how far away is he from the oak tree now? 25 feet. Very good. So 1 hour he's now 25 feet away from the oak tree. All right, but then let's say he goes another hour. He went another 5 feet. So how far is he from the oak tree now? 20 feet. Oh, okay. Hey, are we noticing a pattern? What's our pattern here? He's going down by 5. For every hour of time, he's getting 5 feet closer So another hour passes. He's another 5 feet closer. And another hour passes, and he's 5 feet closer. And yet another hour passes, and he's another 5 feet closer. Until the 6th hour,
He's there.
he arrived at the oak tree where his goodies were waiting for him. Come on, Sean. So this, ladies and gentlemen, is a lovely example of a linear function. What do you suppose linear means? It's a line. That's exactly right. A linear function is a line. You can see the root of the word is line, and that's very important. And this class, we deal almost exclusively in linear functions. We'll learn some others as well, but our big focus, like 75% of our material, is linear functions. All right, this is a linear function, and we want to explain the meaning of the intercepts. Normally, in algebra, we have a horizontal axis that's normally the x-axis, but in this case, we have a time axis. And usually our vertical axis is the y-axis, which is why they're called x and y intercepts. But this particular problem, we're dealing with time on the horizontal and distance on the vertical axis. So right here, this point is a y-intercept. It is where our line intersects the y-axis, or where it intersects our vertical axis. What do you suppose this point right here is called? Yeah, it's the x-intercept. And that's where our graph crosses the horizontal axis, or the x-axis. Okay. What we want to talk about is the meaning of this. So according to our little event that happened here, this y-intercept happened right here. This was our y-intercept. You want to explain what it means? What does it mean? What does it mean? What does...
Where the line is, where the line is, the y.
Yes, that is what we're looking at. But how would you describe this particular point?
Where it starts.
It's where your linear equation crosses that y.
True, but I want to know what happened to the turtle.
Started walking.
He said, I don't know, what do you think?
Where it's at 0 for x-axis.
Okay, so that's where the x is 0, but we don't have an x. We have time. Okay. So when time is 0, what's the turtle at? The turtle's at 30 feet from what? The turtle is 30 feet from the tree. Very good. That's the meaning of our y-intercept in this context. When the time is 0, our turtle is 30 feet from the tree. All right. So with that in mind, here's our x-intercept. The x is 0, or the time is not 0. The time is 6, rather. That's right here. This one happens to be our x-intercept on our table. Now, tell me about the meaning, from the turtle's point of view, of this intercept.
It's when he meets the tree.
When he arrives at the tree, okay, when? After 6 hours. Very good. Okay, so our x-intercept is after 6 hours, the turtle is at the tree, 0 feet from the tree, which is kind of a weird way to say that, but that's okay, it works. at the tree would be fine, but I like 0 feet from the tree. Okay, very good. That's awesome. This was great. I have nothing else to say about this, except this is a rate, 5 feet every hour. We've talked a little bit about rates, and that's something we're going to pay close attention to over the next few days. Okay? All right, other thing I want to point out here. You'll notice that these intercepts happened, this y-intercept occurred when our x-axis, our time axis, was 0, and the x-intercept occurred when the y, or distance axis, was 0. That's really useful information because that's exactly how we graph these quickly. Instead of making a giant list, we can just use zeros. All right, a 0 in place of x and a 0 in place of y. So that is what our goal is today. Example 2, find the x and y intercepts, then graph the function. Find the x and y intercepts, then graph the function. Here you'll notice we have an equation, negative 6x plus 10y equals 30. This equation has x's and y's. All the equations we had before just had x's in them, but this has x and y's. And the reason it has x's and y's is so that we can graph it on a coordinate plane where we have an x-axis and a y-axis. So it's really important to notice those kinds of things. If it has an x and a y, we can put it on an x and a y axis. This equation is in what is called standard form. I'm going to write that right in the middle of the page. Standard form, ax plus by equals c. This is what standard form looks like, and you can see we have the x and the y on the same side, and they're equal to some number. And so if you're lining those things up, on this equation, what number represents the a? Negative 6, good. And what number represents the c?
10.
30, yeah, I tricked you. What number represents the b? 10, very good. That's the number in front of y. Okay, so both of these are in standard form. When we have an equation in standard form, when it looks like this, then finding intercepts is so very easy. We're going to do two things. We're going to find an x-intercept, and we're going to find a y-intercept. If I want to find an x-intercept, all I have to do is set y equal to 0. That's all I have to do. So I'm going to take my equation, and I'm going to exchange the y with a 0, or plug in 0 for y, however you want to say that. Negative 6x plus 10 times 0 equals 30. So instead of a y, we're plugging in a 0. What is negative 10 times 0?
0.
0. That whole thing goes away. What's left? Negative 6x equals
Negative
30. And then how do we solve for x?
Divide.
Divide by?
Negative 6.
Divide by negative 6. Very good.
So always y you're going to divide by 0?
To find the x-intercept, we're going to set y equal to 0, which is weird, right?
Yeah.
Yeah, okay. But you'll notice that it gave me an x. That is the x-intercept, where it crosses the x-axis.
So could you technically do the x as its own problem and the y as its own problem?
Yeah, we will end up doing that. We're kind of going to ignore a term and just do what's left over. Cover up the y and just use one the x piece equal to the number. So you'll sort of see how that is. That is our x-intercept there. So I want to do a similar process to find the y-intercept. How am I going to find the y-intercept? Yeah, set x equal to 0. Using my equation, -6, plug in a 0, plus 10y equals 30. And what happens with the -6 times 0?
It goes away.
It's 0. That's really handy. And we're left with 10y equals 30. And then what do we need to do?
Divide.
By
3.
10. Your brain is a step ahead of me. Okay. Y equals 3. So there is our y-intercept. Now, I do believe sometimes Delta Math might just ask you for the value. The x-intercept is -5. Sometimes it's an ordered pair. All right? As an ordered pair, x first, then y. The x is a -5. What was y? Ooh. 0. We plugged in a 0 for the y. So as an ordered pair, it should always have a 0 in it. For the y-intercept, what was the x? Yeah, we set x equal to 0, and we got a 3 for the y. So be careful depending on what they want. So let's see. We have an x value of -5. Ladies and gentlemen, what is the very middle of the graph called? The origin. Very good. That is the origin. I'm going to write that down because that's super important that we all know the origin is at 0, 0. And then this is a number line to the right. These are positive values, so they go 1, 2, 3, 4, 5. And what's to the left?
Negative value.
Negative values. -1, -2, -3, -4, and -5. Good. What about the y-axis? What's above?
Positive.
Positives, 1, 2, 3, and so on and so forth. And what's below?
Negative.
Negatives. Good. Just making sure. Okay, so if I were to plot my x-intercept at -5 on the x-axis, there's -5 for x and then 0 for the y value. And my y-intercept crosses the y-axis at 0, 3. And all I have to do is connect the dots. Those 2 points determine our line. Pretty easy. Okay? All right, let's try another. We have 5x equals, 5x minus 8y equals 15. We want to find the x-intercept and the y-intercept. How do you find the x-intercept? Set y equal to 0. So we would have 5x minus 8 times 0 equals 15. We're plugging in a 0 for y.
So on Delta Math, would they ask you for both or just one?
Sometimes they're just going to ask you to plot the points, which is kind of nice. You just click and drop a dot, which is kind of nice. And sometimes they'll just ask you, I think, for the number. We'll have to look and see. Yeah. All right, so 8 times 0 is 0, and we're left with just 5x equals 15. Do you suppose it's okay to jump right to here?
Yeah.
Uh-huh. Totally okay to jump right to here. The term with the x and our number on the end, that's just fine. How do we get x by itself?
Divide.
Divide by 5. So we get x equals
3.
3. As an ordered pair, what would that be?
3 and 2.
3, 0. Very good. 3 for the x. 0 was in place of the y. Okay, very good. Let's find the y-intercept. How do you find a y-intercept? Set x to 0. 5 times 0 minus 8y equals 15. What's 5 times 0? 0. What are we left with? Negative 8y equals 15. Again, is it okay to jump right to here?
Yes.
Yeah, you sort of cover up the x term. That'll leave you with a y-intercept. Okay? All right, how do you get y by itself?
Divide by -8.
Divide by -8. Awesome. So we have y equals,
Negative
-15/8.
-1
Let's see. That's kind of weird to graph. How many times does 8 go into 15? Once. With how many remainders?
7.
So -1 and 7/8 as a mixed number. That's a little more graphable. All right. This is an okay number. And sometimes they will turn out like that. That's why I wanted to do one like this. All right, let's see what we've got here. Here's our x, here's our y. This point, is it to the left or is it to the right? To the right. It's here at 3. 1, 2, 3. 3, 0. And then here we have our y-intercept at -1 and 7/8.
This one
Is that up or is that down?
down.
Downward. Okay, so -1, -2. Where's -1 and 7/8?
Just above 2.
Just above 2. Yeah, very close to -2. Right there, roughly. And you will have some that you have to plot between values, okay? So it helps to put it as a mixed number. This is not quite -2. And once you plot those, you'll get your nice little line there. Do the lines always go like this direction? No, they could go downward, all sorts of things. Yes?
Would it allow you to use a decimal or fractions only?
So decimals are interesting. If we have, so this was 15/8. If the decimal terminates, this terminates. This should be fine in Delta Math. If it was like 16/3, does this decimal terminate? No, this is a repeating decimal. It goes on forever. This is not okay in Delta Math. Okay, so this is where fractions are best, and you can always math frac it to get a fraction. Okay? Delta Math loves fractions, and so do I. This is way easier to leave it like this than put it into your calculator to determine the decimal. So, all right, any questions on these? These are pretty easy, right? Okay, I think I have one more here. Or 2 more, I guess. All right, we're going to go in speed mode. X plus 5y equals 6. Ladies and gentlemen, I told you standard form was ax plus by equals c. Ladies and gentlemen, what's the a on this equation? 1. Very good. There's always a number in front. And if you don't see something, you know it could be a 1. All right, let's find the x-intercept and the y-intercept. Can we do the speed method?
Yes.
The x-intercept, all I'm going to do is cover up the term with the y. And I get 1x equals 6. Am I done?
No, divide by 1.
Do I need to?
Oh,
It's the same, right? Either way, I'm good. We're good. Okay. So y-intercept, all I really have to do, cover the x. What's left? 5y equals 6. Now, what do we need to do?
1
Divide by 5, divide by 5. So I get y equals 6/5, which is 1 1/5. I like mixed numbers for graphing's sake. It's a little easier to graph. All right. We have an x intercept of 6. 1, 2, 3, 4, 5, 6. Right there, 6. We have a y-intercept of 1 1/5. Where is that? A little bit above 1. So 1, 2, and 1 1/5 is just a little bit above. 1 1/5, right there. Just a little bit above 1. And then we can connect the dots. Because 2 points determine a line. Great. All right. State the x and y intercept as whole numbers or reduced improper fractions. I wanted to do this one just because the language. Whole numbers. What are whole numbers?
Like 9 or like 7.
9 or 7. So whole numbers. You see in this word, do you see the 0 and the 1? 0, 1, 2, 3, on and on and on. The whole numbers includes the 0. Do you see it right there? The O and the 1?
I don't see the 2 though.
No. You got to make an assumption somewhere. Okay. So whole numbers are fine. Reduced improper fractions. What are improper fractions?
Ones that are like. Isn't it where they have a larger numerator?
Yes. That's right. This is an improper fraction, 6 over 5. This would be a mixed number, okay? We much prefer improper fractions in this level of math, okay? But it's good to remember all of those words. All right, x-intercept, y-intercept, okay. For the x-intercept, what do I do?
Make y is 0.
Make y is 0, which essentially makes that entire term disappear, leaving me 9x equals 27. Then what should we do?
Divide.
Divide by 9, so x equals
3.
3. Great. On this one, you see they have a lovely little box. They just want the 3 in the box. The y-intercept, plug in a 0 for x. It makes that term disappear, so what are we left with?
Negative 6y.
Good. And then we would?
Divide by negative 6.
Good. So y equals negative 27 over 6. Is this okay?
Yes.
No! Oh, you all just killed all the kittens on earth.
No, that's
Simplify. Reduce. Ladies and gentlemen, if you have a calculator, you can always type in negative 27 over 6 and math frack it. It becomes negative 9 halves. Or you can know that both of these are divisible by 3 on top and bottom. So we get negative 27 divided by 3 is negative 9. 6 divided by 3 is 2. And that is our y-intercept, negative 9 halves. All right, ladies and gentlemen, thank you for your attention. You may begin Delta Math 3.1.